Hi, in this lesson we will be looking at the trapezium rule for integration. So by the end of this lesson you should be able to answer exam questions like the one behind me, so stay tuned. Now why trapeziums, or why do we need another rule to work out the area underneath a curve? Now there are certain functions, like for this curve for example, if y is such that it's not easy to integrate. If we can't integrate it, then we can't work out the exact answer to the area underneath the curve. So what we have to do is use a numerical way of working out the area, and one of those methods is called the trapezium rule. What we basically do is we fill up the area underneath the curve with the shapes, in other words with trapeziums, and we work out the area of those trapeziums and add them up, and that gives you an approximation for the area underneath the curve. This is the formula for the trapezium rule. The n stands for, in other words, we need to know how many strips we have or how many trapezium we have in our calculation. So n stands for the number of strips. What we need to do is we need to split this section up into equal width of trapeziums. So if I try to split this up into equal width, again it's not perfectly done, but I'm just doing it off by hand. So let's say that we have 1, 2, 3, 4, we have 5 trapeziums here, so n would be equal to 5. Okay, the h here is the height of the trapezium. Now remember, a trapezium's height is basically the distance between the two parallel sides. So if you look at those lines I've just drawn, I'm going to do this in pink as well, so you can see that this is also part of our trapeziums. Those pink lines are all parallel to each other. The distance between them is basically your height. So the gap between each of those pink lines is basically the h, the height of the trapeziums. So the gap between those two pink lines, or those two parallel sides, is also h. So basically all your trapeziums are equally spaced out. In other words, have equal heights. Now to work out the actual value of the h, we can just use a basic formula. You can see that we're going from x equals a to x equals b. So h, to work out the h, all we have to do is work out the difference between the b and the h. So if we say h equals to b minus a, and then we're splitting this into how many strips, n equals 5. In other words, divide this by n. So this formula, we can use this formula to work out the height of each of those strips. So going back to our trapeziums, now the length of those pink lines here, let's just write them down as y0, y1, y2, y3, y4, and y5. Right, so let's remind ourselves about trapeziums. So if this is our trapezium, let's just side A and the side B. These are the two parallel sides, and the distance between them is our height h. Area of a trapezium is equal to a plus b divided by 2 times by h. Or we can rewrite this as a half of h bracket a plus b. So if you look at our diagram here, we have 1, 2, 3, 4, 5 trapezium strips to find the area of. So let's start with the first trapezium. If we use that notation there, so you can see that each of those trapezium have the same height h. So we have half of h, and a and the b is basically the y0 and the y1. So y0 plus y1 plus, so the second trapezium is a half h times y1 plus y2 plus the third trapezium would be a half h bracket y2 plus y3. And the fourth trapezium would be y3 plus y4 plus the fifth trapezium is a half h times by y4 plus y5. And if you look at all those terms, if we factorize out the half h, we see that we have y0 plus y1 plus another y1, y2 plus another y2, y3 plus another y3, y4 plus another y4. In other words, we have two lots of y2 plus y3 plus y4 and a single y5 and close bracket. And we have a version of the formula for the trapezium rule where we have 5 strips. So basically, what we have to do is in the bracket, add the first y value and add the second y value, and then add on 2 lots of everything else in between, and work out the answer to that, and then multiply by half of the h value, and that gives you the approximation for the area underneath a curve. Now let's apply this trapezium rule on an actual question, and hopefully it will make it much easier to understand how the formula is applied. Alright, so here's the first example. Here we have y equals x squared, and the region R is bounded between the curve, the x-axis, and the lines x equals 1 and x equals to 3. Use the trapezium rule with 4 strips to approximate the area of region R. Right, so imagine we have 4 strips going from x equals 1 all the way to x equals 3. Now, what we need to do first is set up a table of values. The first x value is x equals 1, and we know the last x value needs to be x equals to 3. Now, everything in between, and there needs to be an equal amount of jump from the one value to the next value. And to do that, all we do is plus on the h, plus on the height of your trapeziums. Now, to work out what the actual height is, we can look at the formula. H is equal to b minus a divided by the number of strips. So in this case, we have 3 minus 1. 3 take away 1 divided by the number of strips. So that's 2 divided by 4, which is equal to a half. So our first x value is 1 plus on the height, which is a half. So the second x value would be 1.5. Therefore, the third one will be 2. And we have 2.5, and then we have 3. The corresponding y values are basically the y values that we have in the formula here. So y0 all the way to yn are the corresponding y values here. So when x equals 1, 1 squared is 1. That's basically the y0. When x equals to 1.5, 1.5 squared gives us 2.25. When x equals 2, 2 squared is 4. When x equals 2.5, 2.5 squared is 6.25, and 3 squared is equal to 9. Now, the area of R is therefore approximately equal to half times h. H, remember, is also a half, so half times a half. Now open a bracket, you have the first y value, which is 1, plus 2 lots of all the y values in between. So this is the first y value, this is the last y value. So all ones in between, we have 2 times about 2. So we have 2.25 plus 4 plus 6.25, close the bracket, times everything but 2, plus the last y value, which is 9, and close the bracket. And let's see what that gives us. Right, and that gives us approximately 8.75. So the approximate answer to our area is 8.75. Now let's just extend this question here. Let's add a part B to this one here. What would be the exact area of R? To work out the exact area of R, we have to perform the integration from x equals 1 to x equals 3 of y with respect to x. So integration of x squared dx. So that's going to be x to the power 3 times by a third, 1 and 3. So substitute 3 in. 3 to the power 3 is 27, divided by 3 is 9. So that's 9 minus 1/3. Right, so that gives you 26 over 3. In other words, that's 8 and 2/3. So this is your approximation. This is the exact. Now keep in mind, whenever you ask to work out the exact value, do not turn this into a decimal. Leave it as a fraction or in terms of pi or any other form that doesn't turn this into a decimal. Now there are certain questions which they will ask you to work out the actual error or the percentage error in your approximation. So to work out the percentage error, it's basically equal to the error divided by the original value times 100, and this will give you your answer as a percentage. So in our calculation, to work out the error is basically the difference between the actual value and the approximation. So that's 8 and 2/3 minus 8.75, We then have to divide this by the original, and the original is again 8 2/3. And once you type this into the calculator, multiply this by 100 and then round it to 3SF. So, right, and we get a negative answer. So it's right, so we get minus 9.62%. So the negative sign basically means that our approximation is bigger than the actual value itself. That's why the error is negative. Okay, so let's have a look at the second example. So in this question, we have y is equal to x over the root of 1 plus x. And we have a table of values here. Complete the table below with the y value corresponding to x equals to 1.3. So you have x equals 1.3, work out the corresponding y value. And all we have to do is simply plug this 1.3 into the function for y, which is given here. So you have 1.3 over the square root of 1 plus 1.3 and give your answer to 4 decimal points. So that's 0.8572 if we round it to 4 decimal point. Right, so that's the part A done to the question. Now, use the trapezium rule using all the y values to obtain an approximation for this integration to 3dp. Now, if you look here, we have x equals 1 and x equals 1.5 there. Now, if you look at the trapezium rule, we need to work out what the h is, the height of the trapezium is. Now, the height of the trapezium is given by this formula, b minus a over n. What you notice is that we're not given the number of strips to be used. All it says is use all the y values in the table to find an approximation for the area. So how do we work out the height of each trapezium without knowing how many strips to use? So to do that, if you look at the interval in which the x is jumping by, so from 1 we go to 1.1, we're plussing on 0.1. Here we jump from 1 to 1.2, we're plussing on 0.1 again, and so on. So basically, by looking at the jumps in those x values, we can say that the height of the trapezium is basically 0.1. So we can now jump straight into the trapezium rule. So to work out an approximation for this answer here, we have to do half of the height, which is 0.1, open a bracket, and it's the y value, so 0. Close your bracket, and plus on the last y value, which is 0.9487, and close off the bracket at the end. Okay, and the answer to three decimal place is equal to 0.416.